Hi guys, welcome back to the channel. Today we're gonna start a short series in which you guys can learn important concepts in a very short time. So the first short video will be on hash map. Hash maps are very important in Java while writing code because hash maps allow us to decrease the time complex and optimize the code. So learning hash maps is a very important thing. Today we're going to discuss about what is hash maps and why do we use hash maps and the memory allocation of hash maps. Hash maps, the in the hash maps memory allocation there is a concept called hashing. We'll just skip that part and we'll do it in some other video because it is a topic to be discussed separately. For this video, we'll think hashing as a small method or a function. So just we'll take it as a function, that's it, and we'll use as it is a function, and we'll just learn the memory allocation and everything. So let's just skip everything and start the video. Okay, what is hash map? A hash map is a data structure that stores its items in key value pairs, so that every key maps to a specific value. Um, to get a better understanding about HashMap, if you guys have studied Python before, you guys may have encountered dictionary. So HashMap is basically similar to dictionary. Um, so if to the guys who haven't studied this Python before, let's see example. See, you can see. So this is a key and this is a value. So a key is mapped to a value. So every value is mapped to a key and every key is mapped to a value. So think about your key as a roll number and the value as a student name. So roll number 32 is mapped to the Deepak, a name, and roll number 9 is mapped to Seshu. Roll number 35 is mapped to Vishnu. Roll number 55 is mapped to Nicholas. So every key, so every roll number is mapped to a specific student name. So every key exists should have a value, or every value that exists should have a key. So, and hash map can have different combinations of key and value data type pairs. For suppose here key is integer and value is string. So it has a integer and string combination pair. So it can have string and string combination. It can have string and integer combination. It can also have an object and object combination pair. Many types of combinations can exist in hash map, and hash map is stored in java.util package. So to use it in our code, we should import it by using java.util.hashmap. So and basically it implements from map interface. What is map interface? We'll discuss it in another video. And what is interface? We'll discuss it in another video. So what is implements basically is we all inherit something from our parents, right? We inherit their face structure or some qualities of them, like that. In programming, there is every child class inherits from its parent class, the parent class methods, the parent class data types, and the parent class not the characteristics, the data types and the methods. So basically, this is called inheritance. We'll discuss about inheritance detailed in another video. We should make this video as short as possible. So this is what is a hash map. If you guys didn't get it, don't worry. We'll go into deeper, so you'll get better understanding by the end of the video. So next, why hash map? One more concept we left behind. It is hash map syntax. Hash map syntax is like hash map. The less than greater than symbols in between them, this is key data type, this is key data type, and this is value data type, and this is the reference variable map given to that hash map. And we all know this new is used in java to create the objects, and in java everything is objects, so hash map is also an object. So to create an hash map object we use new keyword, and this is hash map constructor call for calling hash map constructor, and that's it. This is the hash map syntax, easy peasy. And to put some value in the hash map, we use the method put. To put some value in the hash map, we use the method put. So hash map dot add items, hash map reference variable dot put key comma value, key comma value. That's it. Easy peasy, don't get stressed. So let's get to the memory allocation. So let's differentiate between ArrayList and HashMap. So we're gonna take an example of ArrayList of an object type. So we all know like ArrayList can have any like we can store any type with ArrayList. Like we can store with integer type and strings and object types by using the wrapper classes. We can declare them. So here I'm taking an ArrayList, which is an object type. This is gonna be an object type. So this object contains an integer and a string. So this object consists an integer and a string. So my question for you guys is like, find the student with the roll number 104. So we don't know where it is placed. So normally we're gonna use the get function, and we can get the value at that specified index by using this function. So for using this we should know the index value, but we don't know the index value here. So how we are gonna find the roll number student with the roll number 104? So we should do a manual searching. So we'll go to the first element and we'll check its roll number. It is 101. So it is not our desired roll number. So we're gonna cross it, and we're gonna go with the second element, which is 102. And this is also not our desired roll number, so we're gonna cross it, and we'll go to 103. So the third element, which is 103, and we're gonna cross it again. And now we're going to 104, and this is our desired roll number. So we found the roll number, and the student associated with is Punnu. Punnu. At which iteration we got it? The fourth iteration. How many elements are this in array list? Four element. So we took the like maximum number of elements iteration. Like the maximum number of elements is four, so we took four iterations. So what if there is a case of million elements in array list, and we need to find some specific roll number, and it is placed at the last place. So we're gonna take the million iterations. We're gonna need a million iterations. So the time complexity will be O of n. So the like n here, what is n? O of million. So like the time complexity here depends upon number of elements. So the time complexity is O of n. O of n is the time complexity. So to tackle this big problem, which is because O of n complexity is in a very bad case, so we should tackle this with something. So for this, HashMap comes into the picture. We all know that HashMap stores everything within some key value pairs, everything within some key value pair. So what is the key here? Roll number. And what is the value here? Name. So if someone asks us to find something some student name with roll number 104 again, so in HashMap it is done by a single iteration and a single step. So it goes directly to 104, and it goes directly to 104, and it finds the student name. It is Puno. That's it. It just takes an only one iteration. So it is in a constant, it is a constant time taken. So the time complexity here will be of 1. How it is done, we will get a clarity about it when we see the memory allocation of an hash map, so of the hash map. So when we see the memory allocation of the hash map, we're going to get clarity about it. So okay, now comes the most important task, memory allocation. Most people skip this, but this is the most important thing we need to learn as a programmers or developers. So basically, hash maps allocate the memory by important technique called hashing. It is very important, and we'll discuss hashing in a separate video. So you guys just think hashing as a function. You guys think hashing as a function. So for a memory allocation of a hash map, so for any key value pair to get allocated in the memory, there is some steps to be followed. So the first, when we take the key, so hashing is a function. So key is passed to the hashing function. So the hashing function returns a hash number. A hash number. So the hash number decides a bucket in the memory space. Decides a bucket in the memory space. So a block is decided by the hash code. So this is called bucket. So this bucket stores all the entries. So what happens if there are two keys has the same hash code? Yeah, they can have same hash codes. So they can be like a, they are stored in a linked list type. So what is a linked list? It is linked list is basically like an array, but it is having some different implementation. It is a chain of single int data types. So like there is a suppose 2 is linked to 5, 5 is linked to 7. It is a chain of a single int data types or string or something. So as any data type are like that. So it is this is chain but an array type chains. It is implemented in chains, and that's it. If you guys cool, we'll see this in an example. So this is our hash map memory allocation. Say John Smith, I passed the John Smith to a hash function. So when I pass John Smith to the hash function, it returns me 152. So John Smith is passed to 152. So John Smith is passed to hash function and hash function returns me 152. So John Smith is stored in the 152 memory bucket. So and again I have Lisa Smith. I pass Lisa Smith to the hash function. It returns me 001. So I store Lisa Smith its key value pair in the 001 memory bucket. And next Sam Dewey. It is also it returns me the value 254. So um, I store it in the 254 bucket. Next comes Sandra D. So Sandra D is gives when I pass it to the hash function, it returns me the same hash code as the John Smith. So here comes the linked list implementation. See, this is an object. This is an object. This is an object node, and this is another object node. See, these two are linked by a chain. So this is a linked list. If there is an another uh, say another key value pair with the same hash code, they will be linked with another chain. So if the entries of our same hash code, they all will be linked to a linked list, and the linked list will be linked to the specific hash code bucket. So first where key so the first key is converted to a hash. Key is converted to a hash. So the first key is converted to the hash. Key is converted to the hash. Then the number decides a bucket. Yeah, 152 decided to a 152 decided a bucket. Next bucket stores the entries. Yeah, John Smith is decided to the 152 bucket. So the 152 bucket stores the entries. If the same bucket, yeah, so already has the same bucket. So it is stored by a linked list. This is called collision in the hashing. We'll discuss it in the hashing video. So this is how a hash map stores its memory allocation. So now we left a question in the like why the hash map is used step. What is it? How when we how do we search a element in the hash map, and why it is O of one complexity. So if I ask you to find roll number 104 to Purno there, 104 students name. So the basically 104 is converted to the hash. Yeah, 104 is converted to the hash. And obviously by the hash you will list the bucket, and in that bucket you will search the value. So obviously you'll go to the specific hash. So you don't need to know the index value. You just need they give you the key value, and the key is converted to a hash, and you go to the specific hash. You jump to the specific hash. So every time there will be a constant time complexity. So there is an O of one time complexity. In the linked list case, you go to the you go to the specific index, and you search the value by using dot equals method. Dot equals By using the dot equals method, you search in the linked list to get the desired key value pair. So this is how searching is done, and the memory is allocated in the hash maps. So that's it, I guess. There is one. The last thing is that hash. Let's take a fast or look what we did in this video. HashMap stores the values in key. HashMap stores the values in key and value pairs, and HashMap's time complexity for searching is O1. HashMap is stored in java.util package. HashMap is inherited from map interface, and HashMap stores its values by the method hashing, and every key is converted to every key is converted into hash, and hash decides the bucket. And if there is a collision in that bucket, the entries are saved. The entries are saved by using a linked list. Or by using the linked list. And one more thing, in the hash map, keys must be unique. You can't change keys after you initialize them. After you declare allocate them, you can't change the keys should be unique. Keys are immutable. And if you yes, for suppose roll number 11 is Ashish, and now you're giving roll number 11 as some other name, the value of Ashish will be overridden. 11 will be given, 11 is mapped to the new value. So the keys are immutable, the keys are unique, and the values, the key should not be changed. So that's it, and we'll discuss about hashing. So you guys may have doubts in hashing. So hashing will be discussed in a short time. Okay, that's it for today. Thank you. Bye bye. Have a nice day. Like, follow, guys, like, follow, and subscribe. Bye bye.